seats left.
I see. I'll grab one.
Do you three ladies want to start with maybe one back there? Who wants to do it? It's in the offer. You can walk out and maybe you have to do it. And there was another lady that was, she wants to do it. All we have to do is get together. So, you don't want some? You and Tony second. You and Tony second? What I can do is put, blast a message out to everybody in here saying we're gonna start a Living Zone chapter. We're gonna meet, first planning session's gonna be on whatever day. And then we'll just all show up. That way, if anybody else wants to come in, more than merrier. But we could have ran a International Women's Day event. A little bit of money for sure. What I like to do with the one that's first year in it, get something going on. That way, we've got, for that. I wonder what the next one is. I do know we do Dev Fest in probably November. One year we had a all women traffic event. And I went to that again. We could probably plan for that part. Really easy. If we get into that, what, Columbia, what is it, Columbia SC? Yeah. What I don't like is you don't get messages at day one, you get messages on the so you gotta keep going. I'm sure somebody's created a way to do that. Slack for Slacker.
Audio. Alright. Say something in chat.
Hi there.
You got it?
Yeah, yeah, we're live.
That's cool. Oh, that's your webcam on there.
No, it's the GoPro over here.
But it's pointed over.
Yeah, it's
Oh,
pointed
there's a
that way
delay
little-
on it.
Yeah,
Okay.
there's a little bit of delay because that's the live stream. This is a test of a regular audio level. This is a test of a regular audio level. So it's not synced with the video? All right. Is the audio ahead or behind? It's synced? Okay. Do we know who's getting started?
We're gonna start with the video at 6.
All right, do we know whose computer we're running that off of?
I can do it off mine. I just didn't know.
Well, hold on. Evan, who's giving the first talk?
I believe Evan is, and it's not till 7-ish.
Evan, you're giving the first talk. Do you want to run the video off your computer?
We were gonna break the keynote up into a few segments. I can write them.
Okay, well, whatever you want. I can just pull the HDMI. So when you're ready for it.
Yeah, whose is this? Oh, you upgraded? Was that the one you were telling me about?
We need to.
What,
Oh, come on.
could you, what video?
Yeah. Yes.
Just put this in just a tad. Because I need to get this to your computer. Just not going to the camera, but
Oh, you don't have to tap to click. Should figure.
Did that show up for you as a video device?
I can do that if you need me to.
Okay. We're only going to show about 50 minutes of this, so if either you or I have like time slices that we're going to jump to. So we're going to play like the first 20 minutes and then skip some of it and then play like 15 minutes and skip whatever.
Okay.
I have them noted. I can write them down on a piece of paper.
Or I mean, you can do it. I just
Okay, that's fine.
I'll get the display set up for you.
Okay.
I'll go ahead and thank everybody for coming while they're setting up.
Back in.
We're not going to start till 6.
Is he just not recognizing it at all?
It may be because I'm on the highway.
Network with each other. I've got pizza coming here. I'm Tim. I'm the lead
Because, you know, of course we have a backup cable.
Dayton's one of my organizers. And
Anything now?
Nah. Yep. Was it the cable?
Maybe. Let me get the...
maybe 150 in the U.S., North America.
Yeah, I'm not sure. The meetup page says we're one of like 700 something groups. I don't know where that number is. Yeah. But
There's also some.
like communities and other stuff like that. So.
But anyway,
There we go.
we want to bring Google technology to Columbia, so we try to do what we can with what they give us. People's always changing, always stuff like that. So it's always fun to be able to present all that. So today we're going to do some of the keynote from the I/O event. We're going to do some other little videos from that, and we've got about 3 different code labs that we're going to do, and it's going to be fun. So we're going to get into Flutter. We're going to get into TensorFlow, I believe.
TensorFlow Lite, and then I think they're going to do an ML kit.
Machine learning stuff. So it's going to be fun. In the future, just some future things for you. In November is our Dev Fest. We don't have a date yet. We're planning to do what we did last year, have a all-women track, and then have the main course here.
Does he need a
Nothing's been planned yet. We just know
power cable?
we're also planning a Flutter OP event where we do hands-on training.
I'm sure there's another one in there.
Flutter, when you see Flutter, you'll see why. It's going to be a lot of fun. Bring your laptops and learn how to use Flutter. We've got some prizes for everybody when we're done, and we've got some things to raffle off too. So, are you good?
Yeah.
Okay. We're going to go ahead and start the I/O keynote.
Good morning.
Yeah, it's a silent
Morning. Welcome to Google I/O.
Yeah, we're going to switch the audio to the TV real quick. Just system preferences.
Don't help yourselves to drinks or anything.
I did not want to open.
As soon as the pizza.
I mean, I have tap to click on my laptop, and
No,
this
you're
usually just
fine.
messes me up. So,
You got bathroom background? Oh, sure.
okay. The second one, the SE65.
All right. Should be good.
Okay. Let's test it.
Beautiful day. I think warmer than last year. Hope you're all enjoying it. Thank you for joining us. I think we have over 7,000 people here today, as well as many people. We are live streaming this to many locations around the world. So thank you all for joining us today. We have a lot to cover. But before we get started, I had one important business which I wanted to get over with. Towards the end of last year, it came to my attention that we had a major bug in one of our core products. It turns out we got the cheese wrong in our burger emoji. Anyway, we went hard to work. I never knew so many people cared about where the cheese is. We fixed it. The irony of the whole thing is I'm a vegetarian in the first place. So we fixed it, but hopefully we got the cheese right. But as we were working on this came to my attention. I don't even want to tell you the explanation the team gave me as to why the foam is floating about the beer. But we restored the natural laws of physics. So all is well. We can get back to business. We can talk about all the progress since last year's I/O. I'm sure all of you would agree it's been an extraordinary year on many fronts. I'm sure you've all felt it. We're at an important inflection point in computing, and it's exciting to be driving technology forward. And it's made us even more reflective about our responsibilities. Expectations for technology vary greatly depending on where you are in the world or what opportunities are available to you. For someone like me who grew up without a phone, I can distinctly remember how gaining access to technology can make a difference in your lives. And we see this in the work we do around the world. You see it when someone gets access to a smartphone for the first time. And you can feel it in the huge demand for digital skills we see. That's why we've been so focused on bringing digital skills to communities around the world. So far, we have trained over 25 million people, and we expect that number to rise over 60 million in the next 5 years. It's clear technology can be a positive force, but it's equally clear that we just can't be wide-eyed about the innovations technology creates. There are very real and important questions being raised about the impact of these advances and the role they'll play in our lives. So we know the path ahead needs to be navigated carefully and deliberately, and we feel a deep sense of responsibility to get this right. That's the spirit with which we are approaching our core mission to make information more useful, accessible, and beneficial to society. I've always felt that we were fortunate as a company to have a timeless mission that feels as relevant today as when we started. And we're excited about how we can approach our mission with renewed vigor thanks to the progress we see in AI. AI is enabling this for us to do this in new ways, solving problems for our users around the world. Last year at Google I/O, we announced Google AI. It's a collection of our teams and efforts to bring the benefits of AI to everyone. And we want this to work globally, so we are opening AI centers around the world. AI is going to impact many, many fields. And I want to give you a couple of examples today. Healthcare is one of the most important fields AI is going to transform. Last year, we announced our work on diabetic retinopathy. It's a leading cause of blindness, and we use deep learning to help doctors diagnose it earlier. And we've been running field trials since then at Aravind and Sankara hospitals in India, and the field trials are going really well. We are bringing expert diagnosis to places where trained doctors are scarce. It turned out, using the same retinal scans, there were things which humans quite didn't know to look for, but our AI systems offered more insights. Your same eye scan turns out holds information with which we can predict the 5-year risk of you having an adverse cardiovascular event, heart attack or strokes. So to me, the interesting thing is that more than what doctors could find in these eye scans, the machine learning systems offer newer insights This could be the basis for a new non-invasive way to detect cardiovascular risk. And we just published the research, and we are going to be working to bring this to field trials with our partners. Another area where AI can help is to actually help doctors predict medical events. Turns out doctors have a lot of difficult decisions to make, and for them, getting advance notice, say 24 to 48 hours before a patient is likely to get very sick, has a tremendous difference in the outcome. And so we put our machine learning systems to work. We've been working with our partners using de-identified medical records. And it turns out if you go and analyze over 100,000 data points per patient, more than any single doctor could analyze, we can actually quantitatively predict the chance of readmission 24 to 48 hours before, earlier than traditional methods. It gives doctors more time to act. We are publishing our paper on this later today, and we are looking forward to partnering with hospitals and medical institutions. Another area where AI can help is accessibility. We can make day-to-day use cases much easier for people. Let's take a common use case. You come back home in the night and you turn your TV on. It's not that uncommon to see two or more people passionately talking over each other. Imagine if you are hearing impaired and you're relying on closed captioning to understand what's going on. This is how it looks to you.
Danny Ainge level, but he's above the Colangelo level. In other words, he understands enough.
As you can see, it's gibberish. You can't make sense of what's going on. So we have machine learning technology called Looking to Listen. It not only looks for audio cues, but combines it with visual cues to clearly disambiguate the two voices. Let's see how that can work, maybe in YouTube.
Not on a Danny Ainge level, but he's above the Colangelo level. In other words, he understands enough to...
You said it's all right to lose on purpose. You said it's all right to lose on purpose and advertise that to the fans. It's perfectly okay. You said it's okay. We have nothing else to talk about.
We have a lot to talk about. But you can see how we can put technology to work to make an important day-to-day use case profoundly better. The great thing about technology is it's constantly evolving. In fact, we can even apply machine learning to a 200-year-old technology, Morse code, and make an impact in someone's quality of life. Let's take a look.
Hi, I am Tanya. This is my voice. I use Morse code by putting dots and dashes with switches mounted near my head. As a very young child, I used a communication word board. I used a head stick to point to the words. It was very attractive, to say the least. Once Morse code was incorporated into my life, it was a feeling of pure liberation and freedom. I think that is why I like skydiving so much. It is the same kind of feeling. Through skydiving, I met Ken, the love of my life, and partner in crime.
It's always been very, very difficult just to find Morse code devices, to try Morse code.
This is why I had to create my own. With the help from Ken, I have a voice and more independence in my daily life. But most people don't have Ken. It is our hope that we can collaborate with the Gboard team to help people who want to tap into the freedom of using Morse code.
Gboard is the Google keyboard. What we have discovered working on Gboard is that there are entire pockets of population in the world, and when I say pockets, it's like tens of millions of people who have never had access to a keyboard that works in their own language. With Tanya, we've built support in Gboard for Morse code. So it's an input modality that allows you to type in Morse code and get text out with predictions, suggestions. I think it's a beautiful example of where machine learning can really assist someone in a way that a normal keyboard without artificial intelligence wouldn't be able to.
I am very excited to continue on this journey. Many, many people will benefit from this, and that thrills me to no end.
It's a very inspiring story. We are very, very excited to have Tanya and Ken join us today. Tanya and Ken are actually developers. They really worked with our team to harness the power of actually predictive suggestions in Gboard in the context of Morse code. I'm really excited that Gboard with Morse code is available in beta later today. You know, it's great to reinvent products with AI. Gboard is actually a great example of it. Every single day, we offer users, and users choose over 8 billion autocorrections each and every day. Another example of one of our core products, which we are redesigning with AI, is Gmail. We just had a new, fresher look for Gmail, a recent redesign. Hope you're all enjoying using it. We are bringing another feature to Gmail. We call it Smart Compose. So as the name suggests, we use machine learning to start suggesting phrases for you as you type. All you need to do is to hit tab and keep auto-completing. In this case, it understands the subject is Taco Tuesday. It suggests chips, salsa, guacamole. It takes care of mundane things like addresses so that you don't need to worry about it. You can actually focus on what you want to type. I've been loving using it. I've been sending a lot more emails to the company, not sure what the company thinks of it. But it's been great. We are rolling out Smart Compose to all our users this month and hope you enjoy using it as well. Another product which we built from the ground up using AI is Google Photos. Works amazingly well and at scale. You know, if you click on one of these photos, what we call the photo viewer experience, where you're looking at one photo at a time, so that you understand the scale, every single day, there are over 5 billion photos viewed by our users, each and every day. So we want to use AI to help in those moments. So we are bringing a new feature called Suggested Actions, essentially suggesting smart actions right in context for you to act on. Say, for example, you went to a wedding and you're looking through those pictures. We understand your friend Lisa is in the picture, and we offer to share the 3 photos with Lisa, and with one click, those photos can be sent to her. So the anxiety where everyone is trying to get the picture on their phone, I think we can make that better. Say, for example, if the photo in the same wedding, if the photos are underexposed, our AI systems offer a suggestion to fix the brightness right there, one tap, and we can fix the brightness for you. Or if you took a picture of a document which you want to save for later, we can recognize, convert the document to PDF, and make it much easier for you to use later. You know, we want to make all these simple cases delightful. By the way, AI can also deliver unexpected moments. So for example, if you have this picture, cute picture of your kid, we can make it better. We can drop the background color, pop the color, and make the kid even cuter. Or if you happen to have a very special memory, something in black and white, maybe of your mother and grandmother, we can recreate that moment in color and make that moment even more real and special. All these features are going to be rolling out to Google Photos users in the next couple of months. The reason we are able to do this is because for a while, we've been investing in the scale of our computational architecture. This is why last year we talked about our tensor processing units. These are special purpose machine learning chips. These are driving all the product improvements you're seeing today. And we have made it available to our cloud customers. Since the last year, we've been hard at work, and today I'm excited to announce our next generation TPU 3.0. These chips are so powerful that for the first time, we've had to introduce liquid cooling in our data centers. And we put these chips in the form of giant pods. Each of these pods is now 8x more powerful than last year. It's well over 100 petaflops. And this is what allows us to develop better models, larger models, more accurate models, and helps us tackle even bigger problems. And one of the biggest problems we are tackling with AI is the Google Assistant. Our vision for the perfect assistant is that it's naturally conversational, it's there when you need it, so that you can get things done in the real world. And we are working to make it even better. We want the assistant to be something that's natural and comfortable to talk to. And to do that, we need to start with the foundation of the Google Assistant, the voice. Today, that's how most users interact with the assistant. Our current voice is codenamed Holly. She was a real person. She spent months in our studio, and then we stitched those recordings together to create voice. But 18 months ago, we announced a breakthrough from our DeepMind team called WaveNet. Unlike the current systems, WaveNet actually models the underlying raw audio to create a more natural voice. It's closer to how humans speak. The pitch, the pace, even all the pauses that convey meaning. We want to get all of that right. So we've worked hard with WaveNet, and we are adding, as of today, 6 new voices to the Google Assistant. Let's have them say hello.
Good morning, everyone.
I'm your Google Assistant.
Welcome to Shoreline Amphitheater. We hope you'll enjoy Google I/O.
Back to you, Sundar.
Our goal is one day to get the right accents, languages, and dialects right globally. WaveNet can make this much easier. With this technology, we started wondering who we could get into the studio with an amazing voice. Take a look.
Couscous, a type of North African semolina in granules made from crushed durum wheat. I want a puppy with sweet eyes and a fluffy tail who likes my haikus. Don't we all? Happy birthday to the person whose birthday it is. Happy birthday to you. John Legend. He would probably tell you he don't want to brag, but he'll be the best assistant you ever had.
Can you tell me where you live?
You can find me on all kinds of devices, phones, Google Homes, and if I'm lucky, in your heart.
That's right, John Legend's voice is coming to the assistant. Clearly, he didn't spend all the time in the studio answering every possible question that you could ask. But WaveNet allowed us to shorten the studio time, and the model can actually capture the richness of his voice. His voice will be coming later this year in certain contexts so that you can get responses like this.
Good morning, Sundar. Right now in Mountain View, it's 65 with clear skies. Today, it's predicted to be 75 degrees and sunny. At 10 a.m., you have an event called Google I/O Keynote. Then, at 1 p.m., you have margaritas. Have a wonderful day.
I'm looking forward to 1 p.m. So John's voice is coming later this year. I'm really excited we can drive advances like this with AI. We are doing a lot more with the Google Assistant. And to talk to you a little bit more about it, let me invite Scott onto the stage.
Hi Google, call Maddie.
Okay, dialing now.
Hey Google, book a table for 4.
Sounds good.
Hey Google, call my brother.
Hey Google, call my brother.
Text Carol.
Can you text Carol for me too?
Hey Google, who just texted me?
Yo, Google.
Kevin, that was great. We haven't made Yo Google work yet, so you have to say hey.
Hey Google. Hey Google.
Play some Sia. Hey Google, play the next episode.
Play The Crown on Netflix.
All Channing Tatum movies.
Okay.
Yo, Google.
That was great. Can we just get one where you say, hey Google?
Hey Google, find my phone.
Finding now.
Whoa.
Hey Google.
Hey, Google! Yo, Google, lock the front door.
Okay, let's just go with Yo Google then. I'm sure the engineers would love to update everything.
Yo.
Hi, what can I do for you?
We have a pause break now. The pizza's here, so we can everyone can get up and get some food while we fast forward the video a few minutes.
So I'm going to give you a sneak peek into how the assistant on the phone is becoming more immersive, interactive, and proactive. So we're going to switch to another live demo. Hey Google, tell me about Camila Cabello.
According to Wikipedia, Carla Camila Cabello Estrabao is an American singer and songwriter.
So as you can see, we're taking full advantage of the screen to give you a rich and immersive response. Here's another. Turn down the heat.
Sure, cooling the living room down.
And for smart home requests, what you can see here is we're bringing the controls right into your fingertips. And here's one of my favorites. Hey Google, order my usual from Starbucks.
Hello, welcome back to Starbucks. That's one tall, non-fat latte with caramel drizzle. Anything else?
So no thanks.
And are you picking that up at the usual place?
So I'm gonna tap yes.
Okay, your order's in. See you soon.
Yeah. So we're excited to share that we've been working with Starbucks, Dunkin' Donuts, DoorDash, Domino's, and many other partners on a new food pickup and delivery experience for the Google Assistant. We have already started rolling some of these out with many more partners coming soon. Now, rich and interactive responses to my requests are really helpful, but my ideal assistant should also be able to help in a proactive way. So when I'm in the assistant now and swipe up, I now get a visual snapshot of my day. I see helpful suggestions based on the time, my location, and even my recent interactions with the assistant. I also have my reminders, packages, and even notes and lists organized and accessible right here. I love the convenience of having all these details helpfully curated and so easy to get to. Now this new visual experience for the phone is thoughtfully designed with AI at the core. It will launch on Android this summer and iOS later this year. Now sometimes the assistant can actually be more helpful by having a lower visual profile. So like when you're in the car, let's say you should stay focused on driving. So let's say I'm heading home from work. I have Google Maps showing me the fastest route during rush hour traffic. Hey Google, send Nick my ETA and play some hip hop.
Okay, letting Nick know you're 20 minutes away and check out this hip hop music station on YouTube.
So it's so convenient to share my ETA with my husband with just a simple voice command. I'm excited to share that the assistant will come to navigation in Google Maps this summer. So across smart displays, phones, and in Maps, this gives you a sense of how we're making the Google Assistant more visually assistive, sensing when to respond with voice and when to show a more immersive and interactive experience. And with that, I'll turn it back to Sundar. Thank you.
Thanks, Lillian. It's great to see the progress with the assistant. As I said earlier, our vision for our assistant is to help you get things done. It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. You know, we are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when we are done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
Can I hear you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people? When?
Next Wednesday at 6 p.m.
Oh, actually, we need to for like after like 5 people. For people, you can come.
How long is the wait usually to be seated?
When, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Yep. Bye-bye.
Again, that was a real call. We have many of these examples where the calls quite don't go as expected, but the assistant understands the context, the nuance. It knew to ask for wait times in this case and handle the interaction gracefully. But we're still developing this technology, and we actually want to work hard to get this right, get the user experience and the expectation right for both businesses and users. But done correctly, it'll save time for people and generate a lot of value for businesses. We really want it to work in cases, say if you're a busy parent in the morning and your kid is sick and you want to call for a doctor's appointment. So we're going to work hard to get this right. There's a more straightforward case where we can roll this out sooner, where, for example, every single day we get a lot of queries into Google where people are wondering on the opening and closing hours of businesses. But it gets tricky during holidays, and businesses get a lot of calls. So we as Google can make just that one phone call and then update the information for millions of users, and it'll save a small business countless number of calls. So we're going to get moments like this right and make the experience better for users. This is going to be rolling out as an experiment in the coming weeks, and so stay tuned. A common theme across all this is we are working hard to give users back time. We've always been obsessed about that at Google. Search is obsessed about getting users to answers quickly and giving them what they want. Which brings me to another area, digital well-being. Based on our research, we know that people feel tethered to their devices. I'm sure it resonates with all of you. There is increasing social pressure to respond to anything you get right away. People are anxious to stay up to date with all the information out there. They have FOMO, fear of missing out. We think there's a chance for us to do better. We've been talking to people, and some people introduced to us the concept of JOMO, the actual joy of missing out. So we think we can really help users with digital well-being. This is going to be a deep, ongoing effort across all our products and platforms, and we'll need all your help. We think we can help users with their digital well-being in 4 ways. We want to help you understand your habits, focus on what matters, switch off when you need to, and above all, find balance with your family. So let me give a couple of examples. You're going to hear about this from Android a bit later in their upcoming release, but one of my favorite features is Dashboard. In Android, we're actually going to give you full visibility into how you're spending your time. The apps where you're spending your time, the number of times you unlock your phone on a given day, the number of notifications you got, and we're going to really help you deal with this better. You know, apps can also help. YouTube is going to take the lead, and if you choose to do so, it'll actually remind you to take a break. So for example, if you've been watching YouTube for a while, maybe it'll show up and say, hey, it's time to take a break. YouTube is also going to work to combine, if users want to, combine all their notifications in the form of a daily digest, so that if you have 4 notifications, it comes to you once during the day. YouTube is going to roll out all these features this week. You know, we've been doing a lot of work in this area.
I'll keep it paused if anybody wants to go grab some more pizza or something to drink for a minute.
We're going beyond simply predicting the next app to launch to predicting the next action you want to take. We call this feature App Actions. So let's take a look at how it works. At the top of the launcher, you can see 2 actions. One to call my sister Fiona, and another to start a workout on Strava for my evening run. So what's happening here is that the actions are being predicted based on my usage patterns. The phone is adapting to me and trying to help me get to my next task more quickly. As another example, if I connect my headphones, Android will surface an action to resume the album I was listening to. To support App Actions, developers just need to add an actions.xml file to their app. And then actions surface not just in the launcher, but in Smart Text Selection, the Play Store, Google Search, and the Assistant. Take Google Search. We're experimenting with different ways to surface actions for apps you've installed and use a lot. For example, I'm a big Fandango user, so when I search for the new Avengers movie, Infinity War, I get, in addition to regular suggestions, I get an action to the Fandango app to buy tickets. Pretty cool. Actions are a simple but powerful idea for providing deep links into the app given your context. But even more powerful is bringing part of the app UI to the user right there and then. We call this feature Slices. Slices are a new API for developers to define interactive snippets of their app UI that can be surfaced in different places in the OS. In Android P, we're laying the groundwork by showing slices first in search. So let's take a look. Let's say I'm out and about and I need to get a ride to work. If I type Lyft into the Google Search app, I now see a slice from the Lyft app installed on my phone. Lyft is using the Slice API's rich array of UI templates to render a slice of their app in the context of search. And then Lyft is able to give me the price for my trip to work, and the slice is interactive, so I can order the ride directly from it. Pretty nice. The slice templates are versatile, so developers can offer everything from playing a video to, say, checking into a hotel. As another example, if I search for Hawaii, I'll see a slice from Google Photos with my vacation pictures. And we're working with some amazing partners on app actions and slices. And we'll be opening an early access program to developers more broadly next month. So we're excited to see how actions, and in particular slices, will enable a dynamic two-way experience where the app's UI can intelligently show up in context. So that's some of the ways that we're making Android more intelligent, by teaching the operating system to adapt to the user. Machine learning is a powerful tool, but it can also be intimidating and costly for developers to learn and apply. And we want to make these tools accessible and easy to use to those who have little or no expertise in machine learning. So today, I'm really excited to announce MLKit, a new set of APIs available through Firebase. With MLKit, you get on-device APIs to text recognition, face detection, image labeling, and a lot more. And MLKit also supports the ability to tap into Google's cloud-based ML technologies. Architecturally, you can think of MLKit as providing ready-to-use models built on TensorFlow Lite and optimized for mobile. And best of all, MLKit is cross-platform, so it runs on both Android and iOS. We're working with an early set of partners on MLKit and with some really great results. For example, the popular calorie counting app, Lose It, is using our text recognition model to scan nutritional information, and MLKit's custom model APIs to automatically classify 200 different foods through the camera. You'll hear more about MLKit at the developer keynote later today.
Ways that we can help you get things done in the real world. I'd like to invite a partner to stage to share how we're doing this, both in Google Maps and beyond. The cameras in our smartphones, they connect us to the world around us in a very immediate way. They help us save a moment, capture memories, and communicate. But with advances in AI and computer vision that you heard Sundar talk about, we said, what if the cameras can do more? What if the cameras can help us answer questions? Questions like, where am I going? Or what's that in front of me? Let me paint a familiar picture. You exit the subway, you're already running late for an appointment or a tech company conference, that happens. And then your phone says, head south on Market Street. So what do? One problem, you have no idea which way is south. So you look down at the phone, you're looking at that blue dot on the map, and you're starting to walk to see if it's moving in the same direction. If it's not, you're turning around. They've all been there. So we asked ourselves, well, what if the camera can help us here? Our teams have been working really hard to combine the power of the camera, the computer vision, with Street View and Maps to reimagine walking navigation. So here's how it could look like in Google Maps. Let's take a look. You open the camera. You instantly know where you are. No futzing with the phone. All the information on the map, the street names, the directions, right there in front of you. Notice that you also see the map, so that way you stay oriented. You can start to see nearby places, so you see what's around you. And just for fun, our team's been playing with an idea of adding a helpful guide, like that there, so that it can show you the way. Oh, there she goes. Pretty cool. Now, enabling these kinds of experiences, though, GPS alone doesn't cut it. So that's why we've been working on what we call VPS, Visual Positioning System, that can estimate precise positioning and orientation. One way to think about the key insight here is, just like you and I, when we are in an unfamiliar place, you're looking for visual landmarks, looking for the storefront, the building facades, etc. And it's the same idea. VPS uses the visual features in the environment to do the same. So that way we help you figure out exactly where you are and get you exactly where you need to go. Pretty cool. So that's an example how we are using the camera to help you in maps. But we think the camera can also help you do more with what you see. That's why we started working on Google Lens. Now, people are already using it for all sorts of answers, and especially when the questions are difficult to describe in words. Answers like, oh, that cute dog in the park, that's a Labradoodle. Or this building in Chicago is the Wrigley Building, and it's 425 feet tall. Or as my 9-year-old son says these days, that's more than 60 Kevin Durants. Now today, Lens is a capability in Google products like Photos and the Assistant. But we're very excited that starting next week, Lens will be integrated right inside the camera app on the Pixel, the new LG G7, and a lot more devices. This way, it makes it super easy for you to use Lens on things right in front of you already in the camera. Very excited to see this. Now, like voice, vision is a fundamental shift in computing for us. And it's a multi-year journey, but we're already making a lot of progress. So today, I thought I'd show you 3 new features in Google Lens that can give you more answers to more types of questions more quickly. Shall we take a look? All right. Okay, first, Lens can now recognize and understand words. Words are everywhere. If you think about it, traffic signs, posters, restaurant menus, business cards. But now, with smart text selection, you can now connect the words you see with the answers and actions you need. So you can do things like copy and paste from the real world directly into your phone. Just like that. Or, let's say you're looking at, or you can turn a page of words into a page of answers. So for example, you're looking at a restaurant menu. You can quickly tap around, figure out every dish, what it looks like, what are all the ingredients, etc. By the way, as a vegetarian, good to know, ratatouille, just zucchini and tomatoes. Really cool. Now, in these examples, Lens is not just understanding the shape of characters and the letters visually. It's also actually trying to get at the meaning and the context behind these words. And that's where all the language understanding that you heard Scott talk about really comes in handy. Okay, the next feature I want to talk about is called Style Match. And the idea is this. Sometimes your question is not, oh, what's that exact thing? Instead, your question is, what are things like it? You're at your friend's place, you check out this trendy looking lamp, and you want to know things that match that style. And now Lens can help you. Or if you see an outfit that catches your eye, you can simply open the camera, tap on any item, and find out, of course, specific information like reviews, etc. of any specific item, but you can also see all the things and browse around that match that style. Now, there's 2 parts to it, of course. Lens has to search through millions and millions of items, but we kind of know how to do that, search. But the other part actually complicates things, which is there can be different textures, shapes, sizes, angles, lighting conditions, etc. So it's a tough technical problem, but we're making a lot of progress here and really excited about it. So the last thing I want to tell you about today is how we're making Lens work in real time. So as you saw in the Style Match example, you start to see, you open the camera, and you start to see Lens surface proactively all the information instantly. And it even anchors that information to the things that you see. Now this kind of thing, where it's sifting through billions of words, phrases, places, things just in real time to give you what you need, not possible without machine learning. So we are using both on-device intelligence, but also tapping into the power of cloud TPUs, which we announced last year at I/O, to get this done. Really excited. And over time, what we want to do is actually overlay the live results directly on top of things like storefronts, street signs, or a concert poster. So you can simply point your phone at a concert poster of Charlie Puth, and the music video just starts to play, just like that. This is an example of how the camera is not just answering questions, but it is putting the answers right where the questions are. And it's very exciting. So, smart text selection, style match, real-time results. all coming to Lens in the next few weeks. Please check them out. So those are some examples of how Google is applying AI in camera to get things done in the world around you. When it comes to applying AI, mapping, and computer vision to solving problems in the real world, well, it doesn't get more real than self-driving cars. So to tell you all about it, please join me in welcoming the CEO of Waymo, John Krafcik. Thank you.
Hello, everyone. We're so delighted to join our friends at Google on stage here today. And while this is my first time at Shoreline, it actually isn't the first time for our self-driving cars. You see, back in 2009, in the parking lot just outside this theater, some of the very first tests of self-driving technology took place. It was right here where a group of Google engineers, roboticists, and researchers set out on a crazy mission to prove that cars could actually drive themselves. Now, back then, most people thought self-driving cars were nothing more than science fiction. But this dedicated team of dreamers believed that self-driving vehicles could make transportation safer, easier, and more accessible for everyone. And so, the Google Self-Driving Car Project was born. Now, fast forward to 2018, and the Google Self-Driving Car Project is now its own independent alphabet company called Waymo. And we've moved well beyond tinkering and research. Today, Waymo is the only company in the world with a fleet of fully self-driving cars with no one in the driver's seat on public roads. Now, members of the public in Phoenix, Arizona have already started to experience some of these fully self-driving rides too. Let's have a look.
Okay, day one of self-driving, are you ready? Go.
Oh, this is weird.
In the future. Yeah, she was like, is there no one driving that car?
I knew it. I was waiting for it.
Yo, car! Thank you, car.
Thank you.
Pretty cool. All of these people are part of what we call the Waymo Early Rider Program, where members of the public use our self-driving cars in their daily lives. Over the last year, I've had a chance to talk to some of these early riders, and their stories are actually pretty inspiring. One of our early riders, Neha, witnessed a tragic accident when she was just a young teen, which scared her into never getting her driver's license. But now, she takes a Waymo to work every day. And there's Jim and Barbara, who no longer have to worry about losing their ability to get around as they grow older. Then there's the Jackson family. Waymo helps them all navigate their jam-packed schedules, taking Kyla and Joseph to and from school, practices, and meetups with friends. So it's not about science fiction. When we talk about building self-driving technology, these are the people we're building it for. In 2018, self-driving cars are already transforming the way they live and move. So Phoenix will be the first stop for Waymo's driverless transportation service, which is launching later this year. Soon, everyone will be able to call Waymo using our app, and a fully self-driving car will pull up with no one in the driver's seat to whisk them away to their destination. And that's just the beginning. Because at Waymo, we're not just building a better car. We're building a better driver. And that driver can be used in all kinds of applications. Ride-hailing, logistics, personal cars, connecting people to public transportation. And we see our technology as an enabler for all of these different industries. And we intend to partner with lots of different companies to make this self-driving future a reality for everyone. Now we can enable this future because of the breakthroughs and investments we've made in AI. Now, back in those early days, Google was perhaps the only company in the world investing in both AI and self-driving technology at the same time. So when Google started making major advances in machine learning, with speech recognition, computer vision, image search, and more, Waymo is in a unique position to benefit. For example, back in 2013, we were looking for breakthrough technology to help us with pedestrian detection. Luckily for us, Google was already deploying a new technique called deep learning, a type of machine learning that allows you to create neural networks with multiple layers to solve more complex problems. So, our self-driving engineers teamed up with researchers from the Google Brain team, and within a matter of months, we reduced the error rate for detecting pedestrians by 100x. That's right, not 100%, but 100 times. And today, AI plays an even greater role in our self-driving system, unlocking our ability to go truly self-driving. Now, to tell you more about how machine learning makes Waymo the safe and skilled driver that you see on the road today, I'd like to introduce you to Dimitri.
Good morning, everyone. It's great to be here. Now, at Waymo, AI touches every part of our system, from perception to prediction to decision-making to mapping and so much more. Now, to be a capable and safe driver, our cars need a deep semantic understanding of the world around them. Our vehicles need to understand and classify objects, interpret their movements, reason about intent, and predict what they will do in the future. They need to understand how each object interacts with everything else. And finally, our cars need to use all that information to act in a safe and predictable manner. So needless to say, there's a lot that goes into building a self-driving car. And today, I want to tell you about two areas where AI has made a huge impact: perception and prediction. So first, perception. Detecting and classifying objects is a key part of driving. And pedestrians in particular pose a unique challenge because they come in all kinds of shapes, postures, and sizes. So for example, here's a construction worker picking out of a manhole with most of his body obscured. Here's a pedestrian crossing the street, concealed by a plank of wood. And here, we have pedestrians who are dressed in inflatable dinosaur costumes. Right? Now, we haven't taught our cars about the Jurassic period, but can still classify them correctly. We can detect and classify these pedestrians because we apply deep nets to a combination of sensor data. Traditionally in computer vision, neural networks are used just on camera images and video. But our cars have a lot more than just cameras. We also have lasers to measure distance and shapes of objects, and radars to measure their speed. And by applying machine learning to this combination of sensor data, we can accurately detect pedestrians in all forms in real time. A second area where machine learning has been incredibly powerful for Waymo is predicting how people will behave on the road. Now, sometimes people do exactly what you expect them to, and sometimes they don't. Take this example of a car running a red light. Unfortunately, we see this kind of thing more than we'd like. But let me break this down from the car's point of view. Our car is about to proceed straight through an intersection. We have a clear green light, and cross traffic is stopped with a red light. But just as we enter the intersection, all the way in the right corner, we see a vehicle coming fast. Our models understand that this is unusual behavior for a vehicle that should be decelerating. We predict the car will run the red light. So we preemptively slow down, which you can see here with this red fence, and this gives the red light runner room to pass in front of us while it barely avoids hitting another vehicle. And we can detect this kind of anomaly because we've trained our ML models using lots of examples. Today, our fleet has self-driven more than 6 million miles on public roads, which means we've seen hundreds of millions of real-world interactions. To put that in perspective, we drive more miles each day than the average American drives in a year. Now, it takes more than good algorithms to build a self-driving car. We also need really powerful infrastructure. And at Waymo, we use the TensorFlow ecosystem and Google's data centers, including TPUs, to train our neural networks. And with TPUs, we can now train our nets up to 15 times more efficiently. We also use this powerful infrastructure to validate our models in simulation. And in this virtual world, we're driving the equivalent of 25,000 cars all day, every day. All told, we've driven more than 5 billion miles in simulation. And with this kind of scale, both in training and validation of our models, we can quickly and efficiently teach our cars new skills. And one skill we started to tackle is self-driving in difficult weather, such as snow, as you see here. And today, for the first time, I want to show you a behind-the-scenes look at what it's like for our cars to self-drive in snow. This is what our car sees before we apply any filtering. Driving in a snowstorm can be tough because snowflakes can create a lot of noise for our sensors. But when we apply machine learning to this data, this is what our car sees. We can clearly identify each of these vehicles, even through all of the sensor noise. And the quicker we can unlock these types of advanced capabilities, the quicker we can bring our self-driving cars to more cities around the world and to a city near you. And we can't wait to make our self-driving cars available to more people, moving us closer to a future where roads are safer, easier, and more accessible for everyone. Thanks, everyone. So, now, please join me in welcoming back Jen to close out the morning session.
Thanks, Dimitri. It's a great reminder of how AI can play a role in helping people in new ways all the time. I started at Google as an engineering intern almost 19 years ago. And what struck me from almost the very first day I walked in the door was the commitment to push the boundaries on what was possible with technology, combined with a deep focus on building products that had a real impact on people's lives. And as the years have passed, I've seen time and again how technology can play a really transformative role, from the earliest days of things like search and maps to new experiences like the Google Assistant. As I look at the Google of today, I see those same early values alive and well. We continue to work hard, together with all of you, to build products for everyone, and products that matter. We constantly aspire to raise the bar for ourselves even higher, and to contribute to the world and to society in a responsible way. Now, we know that to truly build for everyone, we need lots of perspectives in the mix. And so that's why we broadened I/O this year to include an even wider range of voices. We've invited additional speakers over the next 3 days to talk to you all about the broader role that technology can play in everything from promoting digital well-being to empowering NGOs to achieve their missions. Along with, of course, the hundreds of technical talks that you've come to expect from us at I/O and that we hope you can enjoy and learn from as well. Welcome to I/O 2018. Please enjoy, and I hope you all find some inspiration in the next few days to keep building good things for everyone. Thank you.
That's it for the portion of the keynote that we're going to show. Now we have 2 Code Lab demos that we're going to be presented. After that, we'll have 2 short videos. I think they'll total about 34 minutes. And then third Code Lab, a real short Code Lab kind of overview right after that. I think it's Evan, and then Austin will be presenting after that.
How's everybody doing? Enjoying the keynote? So, my code lab didn't necessarily go as planned. So I'm gonna give a brief overview of what I did and what I did wrong, and hopefully you can learn a little bit from my original demo plan. So originally I intended to demo some of the new ML kit and a custom, basically inserting a custom TensorFlow model into ML kit. So I'm going to show you a little bit of, go to the console here. There we go. Go to the Firebase console here. I probably need to switch my accounts. Won't let me open up Chrome. Switch profiles. Go to console. There we go. Okay. So after the Google I/O event, they added the ML kit here under the development preferences. So you can pull that up and get started. So Drew's going to cover this in his talk, but they have multiple default pre-trained data sets. They have the text recognition, facial detection, barcode scanning, image labeling, and landmark recognition, and all of those are available for the Android API. You're able to pull any of these training sets fairly quickly and fairly simply through Android, which is what he's going to show in a few minutes. And what I initially intended to do was show you how to add a custom model. And so TensorFlow has been updated into this new beta release in order to allow the creation of TensorFlow Lite models. And so a TensorFlow Lite model is different from your standard TensorFlow model because it's compiled into file buffers instead of the protobuffer file type that they have, and that makes it more efficient, so that if I had an iOS or an Android device that has a smaller processor, I can run the file buffers. So I would go here, find whatever model I called it, whatever I call the model, and pull it down. So my original demo involved the Not Hot Dog model from Silicon Valley. I don't know if any of you have seen or heard of that show, but they had a model. I'm gonna open this in Safari. That showed model that if you took a picture of a hot dog, it would tell you if it was a hot dog or not, and if you took a picture of anything else, it would tell you it's not a hot dog. So that was my original training set, and I was able to train a model using someone else's pre-trained data set, and they used a version of a I believe it was a Keynesian model, and I'm going to pull up the repository I just created. Go to my profile. And so it used the Keras model to train the data set. And so I'm actually going to go to his GitHub repo. There it is. And so he used this model and imported the training data from ImageNet. He downloaded all the hot dogs and downloaded all the images repos and images from ImageNet, and then trained the repo or trained a basic neural network. It was only a few layers of convolution and a few layers of two fully connected layers to train this network, and he used grayscaled images. And so I don't know how many of you were here for my bird classifier lab, but we did a little bit of a different. We trained on RGB values, and we used TF-Learn instead of pure TensorFlow like he used in this model. But this model trains a lot faster because it uses it's not a full deep neural network. So in the time constraints I had to create a demo, I trained using this model. However, this model used an older version of TensorFlow, which doesn't support converting to the graph data that's needed to convert to a TensorFlow model. So I don't have a model that I can show you how that I can convert correctly into a TensorFlow Lite model for you. But I can go through the steps on how you would do that, and how you need to make sure you have the most up-to-date TensorFlow version, and that you're running with the most up-to-date TensorFlow API before you can actually convert the TensorFlow model. Had I known this beforehand, I would have corrected the current model, but I didn't. So some things you learn, some things you have to learn on the fly. And so I'll show you where to learn a little bit more about the TensorFlow Lite. So TensorFlow Lite, of course, uses the flat buffers. I believe I may not have said flat buffers, but instead of the prototext buffer that they normally that's the normal format for models in TensorFlow. And so what you need to do. So I thought, train TensorFlow model, any trained TensorFlow model. So I trained a TensorFlow model, and that was not in the correct format, so I couldn't convert it. So trained TensorFlow model goes to a TensorFlow Lite converter, and then that converter takes it to the TensorFlow Lite model file format, and then you can export that model format into your Android and iOS apps, or into Firebase, which is the goal of keeping your models in a decentralized location in comparison to running them on the phone, which is perfectly viable. But if you want to run the models on a server that can do more GPU processing and actually if you were to retrain the data set, then you could do it from Firebase's console eventually, not currently, but eventually. And I believe that's in the scope of down TensorFlow's pipeline, but it's not in the current umbrella of what they do. So and of course they talked about the model tensors that they updated in this rev. So eventually I definitely see them moving that into Firebase and allowing execution and building of an actual neural network on their hardware system. So and of course they have this in their future work as well. So back to getting started with the actual TensorFlow Lite. developer guide. There we go. So they have a few example models. They have the MobileNet model, which is a pre-trained computer vision model. That was not the link to the GitHub page. And it's trained using the same ImageNet classifications that classification that I was doing for the Not Hot Dog, but it's not necessarily the each of these models are adaptable to whatever software architecture that you need to. So say if you wanted to run a basic image classification for hot dogs, you can take these MobileNet pre-built models and expand on them to a greater to more fine-grained classification of your independent model. But the MobileNet gives you kind of the scaffolding of what you need to run these run classifications and other things, and other pre-trained kind of guiding tools for a little bit more advanced TensorFlow interaction. So after you train a custom model, it should export a TF-GraphDef file. If you're using the most recent version of TensorFlow and the most recent version of TensorFlow's APIs. Once this GraphDef file is exported, then you can use the exporting inference graph guide, which is not here. You can look at the SLIM. So this is how you need to build a SLIM image, which means instead of a normal TensorFlow training file is about 250 megs. So it needs to be much smaller than that to fit on a device and not take up a huge application space. So TF Slim, if you're building a model with TF Slim, most of the models are built in Python on the TensorFlow Python library. However, there are C++. C++ is a very strong training library as well because it has a lot less baggage than your Python libraries. And so with the TF Slim model library, you can run your image classification, and you can run your or however whatever network you're training through a Slim library and get a protobuf file that is a lot smaller and has concise variable definitions that you'll need after you've exported the GraphDef, because then you have to convert your GraphDef file into a TensorFlow Lite file. And to convert your there are a few guides to convert your GraphDef file to a TensorFlow Lite file. But what I would suggest is you find a pre-existing converter and modify it to your model. So there are a few guides to doing that, and they give you the freeze graph option here, which you use this command from the Slim package, and it includes the freeze graph Python file, and you'll run input graph whatever your protobuf, because you'll get a PB, which stands for protobuf file format, which is your graph definition, and your last checkpoint. So whenever you run a neural network with TensorFlow, you'll get a list of a deep neural network. You'll get a list of checkpoints that it hits while it's running the classification. And so the biggest problem with the model that I exported initially was that it didn't generate those checkpoint files because it was so small, and it was so and it was again not designed with the most up-to-date TensorFlow version. It ended up outputting just the final TFL file, which can't be used as a checkpoint. So some interesting problems that you run into when trying to rush together a demo at the last minute, but this is this happens, and I can show you a little bit of how the execution worked on the model that I trained, and it was also a very inaccurate model, because when you train for such a short period of time, you get models that well, with a small data set. So there's only 2,000 hot dogs that I had. I only got a 70% accuracy on this model, which is really low in comparison to models that have 95 and 98% prediction accuracy. But so this is how you convert the graph definitions into a TensorFlow Lite model. You can see they basically start a TF session and take the initial TF model and run the Toko convert. And I keep thinking it says Taco convert, but it's Toko convert. And it converts the it runs a TensorFlow protobuf to a TensorFlow Lite file conversion, and it uses the set graph definition and your output here, which again, per model you'll have to define your output. Each model defines their output differently. Here they use the image plus their constants, which are 1, 2, 3, 1, and 4, 4, 4, and they're three-dimensional. So they have a three-dimensional data set here, and they write the output to a TF Lite file, and then you can run Bazel to make sure that your model looks good. Bazel is a tool. Bazel is a nice build system for testing C++ and a few other. Go to the GitHub. For basically running build tests, but in this case it'll be a neural network test of your, and gives a good readout of what the network is going to look like. And so eventually, when you get a TensorFlow Lite output, after you've run through the conversions and make sure your TensorFlow version is correct and you're running the correct model classifications, you can go here and add your model straight from your computer. It should be a lot smaller than 250 megs. So if you end up with a huge TFL and protobuffer file, you're doing something wrong. It's going to be a very small, mobile-sized model. And it's going to be a little bit more concise than the huge protobuffer files that are normally outputted. So I'm going to SSH into, or I'm going to screen share with the machine that I have here. If I can. Maybe I cannot. Okay. I cannot, so let's open up there it is. Open up PyCharm. Gonna open up Not Hot Dog. And so this classifier is a little bit more in depth than the one that I showed you last time, because he does the image blurring by hand, and the image rotations by hand. Instead, what should have been my first sign that it was not going to be a compatible model, but in the TF-Learn libraries, you can actually run the rotation and the blur by hand, or in the actual image pre-processing step, like I should do with the bird classifier. So my terminal window will load. Maybe not. And maybe it will not load. That is strange. It may be because PyCharm is currently indexing these files. So So while we wait on this to index, I'm going to go through a little bit of the differences, and I'm going to pull up the bird classifier as well to give you guys a point of reference who were here last time, and for a point of reference for those who weren't here last time. Sorry. It's still loading the project, so I am gonna not open it in PyCharm and open it in a smaller text editor. There we go. Okay. And again, I'm running macOS 11, so there may be issues. Or sorry, 12, macOS 12. So, so if you take a look here, we used the TF-Learn model when we did the bird classifier. And we did 2 steps of image pre-processing, which were augmentation, which added a random flip of the images and added a random rotation to the images as well as a random blur. And so if you look at the code here, no, we're not going to look at the code there. We're going to look at the code here. If you look at hot dog. I have not recently. He just got back from he went to on vacation to Taiwan recently, and so I don't believe. I think Jana was the last one who spoke with him here in the office. But I've heard he's doing good. I heard he enjoyed his Vision Quest there. So
you have another friend that's in Thailand doing a cycling thing all over.
yes. So so you can see here, instead of using the TF-Learn libraries to actually flip the image and rotate the image, he did that with OpenCV, which is the pretty much the standard for image processing across. It's a C++ library that's used for image processing and image manipulation, and it's widely used and widely accepted. And so he rotates he does a rotation, which is exactly what the TF library does, except it also adds randomness to the rotation, unlike what he does here, and that actually helps with classification and with your training set. So the more variability you have in your training set, the more it can look disillusioned from what it actually appears to be, the more accurate of a guess you can get when you have classified data. And so he also does a blur, and the blur here is also it's also not randomized, but it's pretty and I believe he tried to randomize it at one point, but it does the same effect as the rotation. It gives it's still the same object. It's still classified as the same and would appear to be the same. But when it's run through the classifier, it's then able to be identified different as the your model becomes more attuned to those differences and what it would see in an image when it's processed. And here he does some of the data pre-processing to convert images into the class labels, and then loads the data into using Glob, which is a very nice package tool for Python. It lets you basically pull all of these packages, or all of the JPEG files that I have saved, instead of using a pickled format. However, I'd prefer using a pickled format because pickle is very easy to convert to other models, and it's a nice data set standard for image classification. And if for say I was to redo what this person did in their classifier, I would save the images into a pickle data set that's already classified and go ahead and do the image scaling. So all you have to do is pass the images through to your classifier, and then you're off to the races on a deep neural network training. And the same thing applies for if I was to want to train it on multiple models, because with TF-Learn it's so easy to make a network and run the deep neural network in this case. But if, say, a deep neural network is not what I thought was the best, if I wanted to go back and run a something like just a Bayesian classifier on the objects, which I wouldn't suggest you do with full color images, but if I were to if you were to try and do that, then you can just substitute out the model definitions and run the Bayesian classifier on the smaller model, and use the same Pickle data set. So Pickle is really nice in terms of bringing your data together and into a format that that TensorFlow really can use and start running with. Well, you would scale it and then pickle it. So you would actually still have to do all the pre-processing steps, but when you it's like exporting to an Excel spreadsheet per se. You basically associate an image, you scale the image, and a classification, and then you can just call pickle.load and then open the pickle file whenever, and they're Python objects, so they're already in the Python object format, so you can just access those Python objects, and TensorFlow really likes to just be able to pull Python objects and manipulate them. Right, and you don't have to take that pre-processing step like he does here. So it saves you. I see that it's already broken. It saves you the hassle of having to run these pre-processing steps if you have it in a format that's already in a nice Pickle data set, that you don't have to run the full pre-processing flow every time you want to run the model. And so how many, are any of you familiar with R? R? So it's kind of like an R data set in the same way that you can access an R data set if you export your files to an R data set and import them back into R. They're already in a format that you know you can deal with nicely. Say that one more time. Serialized, yeah, that's exactly what it does, and that's exactly what it is. And so it makes it easier. So if I were to rewrite his training set, I would pickle all that data and then import it so I can run different models on it and test different types of different neural networks and things along those lines. And so he does that. He builds his network with different output depths. So the one thing that the biggest thing that I like about the way that the network is built here is he does it very verbosely. So there's very so in the building process, which I want to show you if I can, it shows each predictive percentage. So it shows the average loss and the average basically a few other data points that show how well the data set is being predicted at this point in the neural network process. And TensorFlow does that too, but there's a lot of excess output data. If you remember from when I ran the bird classification. That kind of muddles the way, and since this is a much simpler network, there's actually less to consume than the bird classification network. But the way that he beautifies the UI when running this is very nice. And the way that TensorFlow, which is we used TF-Learn last time. And TF-Learn is a package built on top of TensorFlow that's used for deep neural network learning, specifically. And so, using the base TensorFlow model, which is what he does here, is not built for deep neural network learning, but you still can do deep neural network learning. And so it's a little bit more verbose on how, you have to define a convolution in 2D. From a sequential instead of just a convolution 2D related to the network here, that in each layer is passed to the network, you can define this singular model and run it, and you run it through its own image, and we're not going to deal with PyCharm right now. I apologize for the inconvenience here. Oh no. Oh no. Force quit. So there you can run a Bayesian classifier like your standard naive Bayes, and a few. So I believe you can do a linear regression. You can do a you can do your standard. They have support for all of your logarithmic regressions, and I believe that and your trees. But their specialization, and this is kind of how the machine learning industry is going towards, is what it's going towards as well, is neural networks and building however you want to classify your data is kind of their goal for their open source goal. So so they do have support for, just like SciPy, they have support for running decision trees and your general classifiers on the tensor as well. But again, their specialization is actually that machine learning, so the actual supervised learning and not the or the actual unsupervised learning and not the supervised learning, which tends to be the category of your decision trees and your linear regressions and things like that. So since this is not loading, does anybody have any other questions about TensorFlow or TensorLite MLKit? I have loaded Python and the correct repositories, but I have not done a training set on a Windows computer. There are guides to do so, but there are some differences. So like if I wanted to use OpenCV, you'd have to install that via Windows installer instead of through the same bash formats that you're used to. And running on the GPU is going to be a little bit different on a Windows machine, and that's what I suggest if you're running any large models or any large classifications of data classification, is you run it on a GPU and not a CPU, because otherwise it will take a few hours to actually run the training. Yes, so that's the preference, and you actually pay for compute time though. So AWS and Google both offer hosted tensor solutions that you can actually run your models on. And so if you were doing this at scale, if you were trying to actually run a production level prediction of some data that you were collecting, say for financial, say you're collecting data for a financial institution and you want to predict market trends based off of something that's not a simple time-based classifier. If you wanted to actually see if you could learn the data, then you would have hundreds of millions of data points that you would need to run fairly quickly through a cloud TPU. So I'll actually pull up a cloud. So Google, of course, is the first pricing guide. And basically, it's still in beta. Their cloud TPUs, which is their newest way, but you can open up a Cloud Shell. So this is a project I had for deep neural network visualization, and then get a config. So this is the general configuration, and so this is straight from the Google Cloud Platform. I don't know if you've dived into Google Cloud Platform, but they're trade-offs. So Google Cloud Platform billing is a little bit different, and it's not the same structure as AWS if that's where your experience lies. And it also there's some documentation issues being Google, and there's also a few, but they've gotten better. They've gotten a lot better, and there are just a different hosting platform. So instead of your AWS AMIs, you're going to get Google's default Ubuntu instances and things like that. So, but comparably, the Cloud Platform dashboard looks like this. You can see your App Engine services, your Compute Engine, Kubernetes Engine, Cloud Functions, all of that fun stuff, and now your TPUs. So if you wanted to run a actual TensorFlow model, like I just spun up a TPU in a few minutes by clicking Open Shell, and they have a TPU available for me. And so they're comparable. Their hosting costs are different depending on what you're doing. And then if I were actually running a TensorFlow computation, so let's look at the pricing. And so let me, I want to actually pull up AWS's Cloud TPU. There we go. And so they now have SageMaker, which is based off of the cloud TPUs that allows you to build ML models on AWS's machines. And I'm trying to find the GPU that I trained on. Yeah, okay. So I trained on a P3 instance. And so because you're going to need the GPU performance over anything, especially for image classification. If you were doing, depending on the type of classifications, a CPU can perform better, or RAM can perform better, but for most of your audio and your visual computations, GPUs are just insane. Much faster than your average CPU when running deep neural networks. But both Google and Amazon offer these solutions. So and I believe even CloudSource. the provider, Cloudflare, that's it. I believe they offer a GPU solution as well. I wouldn't be surprised if Microsoft and Azure and a few other cloud-based solutions also do the same, because they're following the lead of Google and Amazon, who both are investing heavily in machine learning at this point. Any other questions? Nope. I think Drew, come save the Code Lab. Again, I'm sorry that the actual Code Lab part of the Code Lab didn't work out, but
Well, sometimes it's good to learn what not to do.
yes, so you don't repeat my mistakes.
Yes. That is the Sichuan ghost pepper sauce. Hopefully that's part of the demo. It is. No. No. Oh, Lord. Theoretically that works. There it goes. Oh, it potatoed my screen. Hold on. Workspace? Will this work? Yeah. Alright, that'll work. Alright. For those who haven't heard from me before, my name is Drew. I am the lead Android developer here at 52. And today I'm going to be talking about MLKit, more specifically its implementation on Android. So what is MLKit? As you probably saw in the video, I think it's machine learning for peasants. It provides an easy and simple interface for using machine learning tasks, such as he showed before, is being able to easily implement your own custom model in Android by just calling through the simplified Firebase API. But today I'm going to be focusing on the built-in kind of machine learning tasks that you can do, such as recognizing text. So if you wanted to like take a picture of a sign or say a nutrition label and scan the text out of it and use it, detecting faces, and that can go from anything from saying how many faces are in the picture to where they are in the picture, what kind of facial expressions they're doing. Are they winking? Are they smiling, frowning? Coordinates of cheeks is the kind of stuff that powers Snapchat and other apps where they do the like built-in face modeling stuff. Scanning barcodes, which seems very simple. I was just like, is that really something machine learning task needs? But it gets a little bit more involved, where it can scan any type, determine what it is, no matter the orientation of it in the photo. Then there's stuff like identifying image content. So like if you take a picture, it'll try to give you labels of like what's in that picture. So as I have my props, I'll show you a demonstration of that later on. Landmarks, so it does one where like if you took a picture of, I assume, if I haven't really read into like all the landmarks, but if you took a picture of like the Empire State Building, it'd be like, this is what it is, where it is, and so on. And then of course the custom TensorFlow that Evan went over earlier. So in my code lab, I'll be focusing on the facial detection and the image labels. Yeah, and so that's another cool thing. If you have Android, there's an app called Lose It, which is like a meal
calorie tracking app, and they added in the ML kit to where you can scan your nutritional labels. Say if there's like a food you can't find and you just want to be like, oh, here it is, it'll scan it and automatically put it in so you can log it, which is really cool. Yeah, I kind of breezed through all of these. So here's a list of all the categories and some example labels for the label detection for different things. I didn't have enough time to put this together, but as we were trying to do hot dog, not hot dog, I thought maybe I could feed it an image of hot dogs and see what this would feed out. But I went a little more simple just to demonstrate it. So let's get to it. All right. If you go to Firebase.com, you can pretty easily navigate through the docs to find all the ML kit documentation, and I'll go through there on how to set up the SDKs. It's just a couple lines of imports. I'm not going to go through the basics of starting an Android project, but here I just created a brand new project with an empty activity, and then in your build file you just add these two lines here, and now I have instant vision detection and facial detection or recognition stuff. Actually,
so you don't have to load in your in that block there. It doesn't matter what the order.
No. That's just a list. It doesn't matter. My goodness. Hold on. Sure. I made some changes before I started this, and I need to pull them down. Oh. Don't care. Alright. Sync this, and I will put it into... Alright. So here I just created a simple activity. And the first thing you'll need to do, also by the way, this is all written completely in Kotlin, if you didn't visit my Kotlin talk at last DevFest, but it's amazing. So first thing we need to do is we need to get an instance of the face detector. And it's pretty simple. You just call this builder option, and you can give it the classification kind of stuff you want, where I think this kind of determines, like, do you want to know about where all the different facial features are and all these, just more in-depth analysis. And the drawback is it might take a little more time to process it based on these. And you can also include landmarks, so it can also try to analyze landmarks out of it. Out of, like, if you're taking selfies, it could be like, oh, here's your face and here's a landmark. I just opt to do no, because I don't need that and it's faster. Now, the face detector one I have on here is using the local model support. So with this, with these 5 built-in features, they all have local support, which is enabled by default. So that's where it just kind of downloads the pre-trained model from Google onto your device, and it's ran on the native code with TensorFlow Lite. All behind the scenes automatically, so it's very quick, but it's also very limited. Then there's the cloud-based version where it uses the Firebase API to use the more enhanced version running in the Firebase kind of server stuff that Evan showed earlier. And same thing with all the image labels. I think, just to give you an idea of that, here is a list of what it can really do locally with the kind of object detection. If you're just running it locally, which is completely free to use, If you want to use the cloud stuff, you have to have the Blaze billing plan enabled on your Firebase account, and it gives you a lot more options. So if we go, we get our facial detector. I'm not going to go over all the code. I basically ask the camera app to snap an image, and it feeds me the bitmap back later. That you can see here. And here we just create a Firebase Vision image from that bitmap, and then we just feed it to our detector and listen for the success. And here for the text, I did something fun where if it detects that you're smiling, it'll put a smiling emoji. If it detects that you're smiling and winking in one eye, it'll do a winky face. If you're frowning, it'll give a frowny face. If you have both your eyes closed and you're frowning, it'll be the like closed eye frowny face. And it's built in to do multiple faces. So if you have a selfie with two people, it'll put in two emojis or however many emojis. And if you go into the docs, they have sample code where they do a lot more, where they'll show you a live preview of the camera feed and actively draw on your faces when it detects stuff. But I thought that was a bit more involved. So I will show you how this goes. Hold on. Wrong phone. All right. Free software, huh? All right. Everybody see that pretty well? All right. So here is our app. So we just tap take a photo. Hit enter. And bam. Automatic smiley. Now we'll do frowny face and the frowny smiley. Now I think, let's see if I can get it to do this. No, of course not. But I think this one will work. Yeah, there we go. And so that just gives you, a percent of confidence on all those different values on like whether it thinks you're smiling or not. And so that's how I basically played off of it. And so if you ignore the camera capture stuff, which is pretty straightforward, this is not a lot of code to achieve very simple facial recognition. And it's not too much more to get more details on that and use into your apps. So I thought that was pretty awesome. I always thought that facial recognition was a very daunting task to implement. And here it is basically just a few lines of code. So next, which I find the more interesting one, is the image label stuff. And so this is a near identical to the previous activity in Screen. I pretty much took the same camera capture code. You take an image, you feed it in. This time I'm using the cloud label detector, and you can use, if you omit the cloud keyword, you get the onboard label detector. But here I will show you an example of the cloud one. Same kind of stuff. We get the image, we feed it into there, and then I just show a list of all the different labels that it spits out for me. So here, I'll take a photo. And since it does do the cloud, it does take a bit of time. Let's see, it found yellow in the photo, so it does take a bit of time to send the image up, have it processed, and give it back down. But you get a lot more options that way, and like, as Evan kind of explained, it's kind of a computational heavy task. So let's see if I can get a good shot of my Iron Man Lego. Toy Lego. space. Close enough. He went into space a few times. And so, like, I tried this with the local one, and it wouldn't even really tell me what this was. It just said toy. The Pokemon card came back with nothing. I took a bit of a water bottle, and it was like tableware. So it's very simple, a lot simpler. So let's see if I can do a few more here. So that's pretty close. It's not if only. But I don't think my boss would approve of that. Yeah, that came up with a lot more. And I tried the phone before, and it was like mobile phone technology electronic device. So it definitely gives you a lot more processing and a lot more actions. Here's one I wanted to try when I get up here. So let's see if we can take a photo of the crowd. Uh-oh.
Trying to steal my soul, steal my soul.
I've got it.
Service competition.
It's not perfect. Yeah, so that's basically it. If I go through some of these other things, it'll pick up the sunglasses. It doesn't quite know what hot sauce is, but it knows it's a glass bottle and maybe beer. It just really wants to find beer. Yeah, so that's pretty much the gist to it, and all the other basic implementations are kind of the same. You configure a different set of options, the different kind of detector, and you just feed it the image. And I believe some of them, the facial recognition, which can do tracking, I believe. Yeah, so the facial recognition stuff is efficient enough now that you can feed it. You can feed like a live camera feed into it, and it'll actively track faces in it, and like in real time, and not using the cloud, which is all local, which is pretty awesome. I think the text recognition's like that too, but the label and the landmark stuff take a bit of time to query. But I just thought it was so cool that you can access all 5 of these kind of seemingly impossible tasks only a few years ago, with just a few lines of code. Now, if you're feeding raw image camera feed into it, that's a whole lot more involved process that I won't get into, because the camera APIs on Android suck. But that's pretty much the gist of it, of the rundown of MLKit on Android. I look forward to using it. And of course, it has giant, big old beta flag on it, and not to use it in production, but hey, it's fun. But that's pretty much it. That's the extent of.
Just go with Firebase.
Yeah. So, if you go to Firebase and then go to the docs, go down to their products, right over here is MLKit, and it's available for both iOS and Android, no matter what platform you're working with. We didn't get enough time today to try to, we were trying to coordinate and feed a custom model into it, and then same thing here, you just feed an image and just using the simple API feed it up, and I get whatever output that his model decides to spit back and be able to process. But training machine learning models takes time.
And we quickly ran out. Is that one against like constantly training models that Google's got going on? Is that what you're trying to
Yeah, that's what those five features, the text, faces, barcodes, the labels, those are all running against Google's models. So it's like, I believe it's the same models that power the Google Photos app. If you've ever seen that, that does amazing recognition. So as far as I understand it, it's running against the same thing.
And they may not be constantly training it. They may be aggregating data and then retraining the model because, again, it's very expensive
So here's a cool example on their site is a photo of Stephen Hawking doing zero grav. And here's like an example, kind of a brief overview of the data it spits out for that image. And it's 1 of 3, and it gives you the bounding polygon for the face. Its tracking idea. It gives you the rotation of the face in reference to the camera in 3-dimensional vectors.
So is that the dimension of the eye?
Yeah, so left eye. So I believe so in reference to the photo. So it's like that's where, I don't know which face it's referencing right now, but that's where that eye is in the photo. So you can see if you're trying to do some kind of thing of like tracking and superimposing stuff on people's faces, it gets you pretty close. And that's what yeah, and that's what this API lets you do is feed a real-time camera feed into it, and it'll live spit that info at you constantly. No, that's using the local model. So there's when you go through the docs, there's a flag you put in your app manifest, and that basically when your apps first launch, it just pre-pulls that model down, or if you go and first request it, it'll pull the model down, and then it's just all running really quickly. As you saw with when I did my face demo, as soon as it got back to the app from the camera, it had it like that. So it's that fast enough. At least the face stuff is. The other one takes a bit of time, but yeah, see, it's performed on the device and it's fast enough to be used in real-time applications such as video manipulation. So yeah, if you wanted to do some kind of Snapchat-esque facial filter kind of stuff, this is probably your best bet to get into that. Because where Snapchat was probably originally doing their own models and tracking or whatever, I'd have to look into what they used. But you get to leverage Google's pre-trained stuff, which is pretty awesome. Okay. So I misunderstood this. Whenever you were specifying landmarks on a face, that's where it feeds you back with the position of where your left eye is, where your right eye is, base of the nose, like just where the features are in the image. So that's what you would use to kind of position or track. That's pretty much the dirty rundown of it.
Thanks a lot. That was good.
Yeah. Yeah, here's an example of the image stuff. It's just a soccer photo of the image, and it just shows all the labels and gives you a % confidence in that those labels are. Which is probably something I could have done is sorted the labels based on confidence, but demos. But that's the gist of it. It's pretty straightforward. It was a lot easier than I initially thought it was going to be.
And then converting your 10-foot models to potential light models is a lot more difficult than I initially thought it was going to be.
Yeah, that's a whole nother beast, is doing your own custom thing. But that's it. Any questions or streams? Okay. Cool. I can take more photos of stuff. It'll implode. Hold on. Let me gather my props. it's this one right here.
Oh, sorry.
Yep.
Hello, my name's Dayton Pruitt. I recently just started, some of you may have noticed there's a new Google Cloud, GDG Cloud group here in Columbia. Yes, I started it. This was a joint meetup with the GDG Columbia group. They're starting, last year there was a push to get some cloud meetups throughout the US and worldwide, and that kind of, I guess they kind of changed management within the company. They didn't get the interest that they wanted, so they had a newer drive this year to get, and I think they have 15 of them in the US. I don't know the exact total. There's, I think, over 40 of them worldwide, and so I got one approved the week before I went out to, well, the week before I.O. was this year, and this is the first meetup that we've had, and it's a joint meetup with the regular group. And one of the plans, Tim and I were talking, is to have maybe 10 to 12 meetups a year, and one group would have 5 or 6 and the other group would have 5 or 6, and some of the bigger ones, like these extended events like the maybe the DevFest, the Google I/O extended, and then the Cloud Next extended, we would do joint meetups. And then the other ones, we would have the GDG Columbia would do a lot of Android and other assistant and software related stuff, and then the cloud one would focus mostly on cloud and other things related in that area. So one of the things they showed a demo last year. I have 2 videos. We're going to try to stop around 9 o'clock. One of these videos that we were going to show is about 34 minutes long, so we can show that or show part of it if you want. This other video is, I believe, only like 3 minutes, 2 minutes. But one of these new if you're familiar with like Xamarin or Apache Cordova, tools like that, they allow you to write one application that can compile into multiple mobile platforms. Well, last year Google started a project where they use their Dart language, which compiles down to I believe it's a Java language, but it's actually a language they've written in-house, and it used to use Eclipse, and now you can use Android Studio and Visual Studio Code, which was one of the first products that a lot of people were using, because you can take the SDK and run it natively, pull it in and put it as a plugin in Visual Studio Code. And this year they released, I think it was February, they released a 0.1 beta of a SDK called Flutter, which uses Dart, which is Google's entry into the cross-platform mobile development platform. And let's show you a little video here real quick. Oh, I need to turn my microphone on. Let's see.
Mobile users expect their apps to have beautiful designs, smooth animations, and great performance. To deliver on this, developers need to create new features faster than ever without compromising on quality or performance. That's why we built Flutter. Flutter is Google's mobile UI framework that provides a fast and expressive way for developers to build native apps on both iOS and Android. This is because apps and interfaces made with Flutter are built from a single codebase, compiled directly to native ARM code, use the GPU, and can access platform APIs and services. Here are 3 ways that Flutter will help you on day 1. Flutter is engineered for high developer velocity. Stateful Hot Reload allows you to change your code and see it come to life in less than a second without losing the state of the app. Flutter also ships with a rich set of customizable widgets, all built from our modern reactive framework. Plus, Flutter integrates with popular development tools, which means you can get started quickly with the editor or IDE you already know and love. Flutter moves the widgets, rendering, animation, and gestures into the framework to give you complete control over every pixel on the screen. This means you have flexibility to build custom designs. Flutter apps follow platform conventions and interface details such as scrolling, navigation, icons, fonts, and more. This is why apps built with Flutter are featured on both the App Store and Google Play Store. Flutter is great for developers both new and experienced in mobile. If you're new to mobile, Flutter gives you a fast, fun, and modern way to deliver native apps. If you're an experienced mobile developer, you can add Flutter to your existing workflows and tools to build new expressive UIs. Flutter is free and open source and used by developers and organizations around the world, including enterprise, agencies, and startups. Visit flutter.io to get started today. We can't wait to see what you build.
So I have another video. I'll give part of it. The Code Labs that my demo is based on take about 80 minutes, and I wasn't planning to take that long to do it. I was going to kind of go through some stuff that they have on the Flutter website and show you, for those that are interested and want to like set it up on their own computers, get it installed, what you need. They have very good instructions on their website to help you walk through the process of downloading the file, getting it set up. Then it has you all the instructions for all the different IDEs that you may, like if you want to use Android Studio or Visual Studio Code, whichever one of those you may prefer or already have installed. It gives you the instructions for taking the SDK plugins and applying it so you can use that specific IDE, and then it walks through a starter app and then kind of shows you that, and then there's like a whole first app thing, which is it's actually 2 Code Labs, and then they have a total of 9 Code Labs, I think, for, is it 9? Let's see. All right. I think it's 9 or 11, I can't remember. Yeah, there's 9 Code Labs. There's 5 Flutter ones, and then these ones in black here. And I'll go over this in a minute. These ones with the black bars are kind of Flutter with material design. But 2 of these are the main part. But I'll show a little bit of the video because I think this is a really good video. They integrate a Flutter app with a chat component using Firebase chat or Firebase messaging.
Hello and welcome to Total Mobile Dev Made Fun with Flutter and Firebase. I'm Emily Shack.
I'm Emily Fortuna.
And today we are going to show you just how easy and fun it can be to build your very own mobile app using Flutter live here on stage. But to kick things off, we're going to tell you a little story about our friend Francine.
Now, Francine was the proud owner of a pet store, and she realized the one thing that she needed for her business was to write a mobile app that would allow people to see her inventory, reserve fish that they were interested, and so then when they came into the store, they would be on hold and they could adopt them. Now, I know that Google I/O is the worldwide gathering of aquarium enthusiasts.
I'm not sure that's quite right, but I do know that we have a lot of mobile developers in the audience, so I think they'll still appreciate this.
All right, well, so it's still relevant. So today we'll be live coding a pet adoption app for fish for Francine on stage. So let's switch over to the devices and we can see the app that we'll be live coding today. As you see, we have these nice cards with information about the fish. There are nice animations as you can slide between the information about the fish. Some of the fish are even animated. And if you decide that a fish is the right one for you, you can hit that catch button and then it is reserved. Then you can hop over and you can see that it has disappeared from the view of the other phone, so no one else can reserve that same fish. Now if you hop over reserve, view, which Emily has, you can see that the fish that she's reserved is available. And if she decides that Dart is not actually the fish that's right for her, then she can swipe up, and it has been cleared from your reservation. And if you decide that you have regret from if you let loose the wrong fish, you can shake, and your fish is back reserved. And as you notice, there are all these great sound effects to go along with all of your actions. So let's hop back to the slides. So whether you are creating an app to create a home for unloved marine animals or just coding up that app that you've been talking about for years, what we hope you'll find today is just how easy it is with Flutter to make your vision a reality. One of the great things about Flutter is you can get a native look and feel for both iOS and Android all from a single code base. So you don't have to learn multiple new technologies just to get an app that can serve all of your users. And not only is it a native look and feel, it is an actual, Flutter compiles down to native code. So you don't have to sacrifice quality to get a great looking app. One of the reasons that I always look forward to developing in Flutter is hot reload. So all I have to do is type my code into the IDE, hit save, and then it's instantaneously on my phone. The only downside is I no longer have time to make coffee because my code's already running.
Flutter also has many powerful components that you can integrate with that go beyond the scope of Flutter itself. In this talk, we're going to be showing you how to integrate Cloud Firestore, which is an option for your server-side component of your app. You can also integrate the accelerometer. That's how we're showing you shake to undo. And we're also going to integrate those crucial sound effects for the flushing of that fish. And all of this is done in the same code base so that you don't have to deal with the hairy details of those device platform-specific APIs. So I'm going to jump on over to the code base, and we're going to give you a little tour of what we're going to be coding before we go ahead and dive into the coding portion.
So we went ahead and wrote some class declarations for you because watching us type class declarations is kind of boring, but we'll do a quick overview of what the file looks like. So at the top, we have our main function, our entry point. That's where we're going to be building our top-level widget or component that we're drawing in our app. Our top-level widget is very creatively called My App. My App is in charge of getting the information from Cloud Firestore, or aka Francine's fish database, and then telling to draw that app as to screen. My App has a fish page and a corresponding fish page state. Now, you'll notice that fish page is a stateful widget, whereas all the other widgets you see are stateless widgets. If you remember when we demoed, we had that undo functionality. And so that's some information that we need to store and have a long-running persistent action to what we last did to the fish. So if we decide that we need to undo that, we have that. So for this reason, we're storing that in fish page so we can have that long-running persistent state. For everything else, we have stateless widgets so that it can just draw to screen whatever information we provide it. Fish page has a fish options. That is that center section that allows you to scroll through all the available fish that you are able to adopt. And then fish options is made up of many profile cards, and that's the individual cards that you have for your fish. Now, there's probably a few more class declarations in here than you would want to have if you were coding this app for real, but for the sake of live coding, we're putting it all in one file so that it's easy for us to jump around and for you to see what's going on. We do have one more file though. Hop over to the utils class. There are two classes in it. Fish data is just a convenience class, so when we're writing information to Cloud Firestore, it's going to be in the form of a map. And so fish data takes that map and converts it into a Dart object, and then when we want to write it back to Cloud Firestore, we convert it back to a map. Local audio tools is just a wrapper around the audio tools function, or plugin, which allows us to play audio files locally from our devices. So let's go back to main, and Emily has our app running up on this devices, so let's switch over to the device view and see what we've got.
Okay, I think this is a pretty good app to start out with. Obviously, we have a long way to go here. One thing that I'm noticing right off the bat, though, is that the text in that app bar and in that button at the bottom is a little bit larger than I might have on apps on my phone. Why is that?
That's a good question. So actually, this is a good illustration of Flutter's accessibility features. So if you are vision impaired, or if you are giving a presentation, you want to make sure the people in the back rows are able to see the text, you can set the text size, default text size on your phone to be larger. And Flutter will respond to this and then increase all the text size in the app. So we increase the text size without changing anything in our code itself.
Okay, so I know that I can read this app, but there's not really much here that I'm reading yet. Why don't we go ahead and get some content in there? I think the most important thing to start out with is that we have some nautical theming in the background to really show that we're shopping for fish.
Sounds good. So we can do that by setting the color of that center section. So we're in fish page state, there's a build method. This is the method that gets called when Flutter wants to draw this widget to screen. Build method exists for every single widget that you have. So here we are constructing a scaffold that provides the outline for its children widgets and where they should be displayed on the screen. Scaffold has an app bar, that's that title bar at the top giving the name of our app. Then we have the bottom navigation bar that allows us to toggle between the two individual views. And then at the bottom we have this fish options as that main body. So to set the color, Emily's going to wrap this in a container and set the color of the container. Now, why are we wrapping this in another widget rather than just setting the color of fish options directly? This is actually a common design pattern in Flutter to favor composition over inheritance. And if you can imagine, we could potentially have parameters in fish options to set the color and the width and the padding, but you could then maybe have 100 parameters and it could get pretty overwhelming. Having a composition in the way we build our widgets keeps our APIs much leaner, and it allows us to build a combination of widgets in ways that the API designer maybe originally had never envisioned. So Emily specified Indigo, she's ready, she's hit save, hot reload is happening, let's switch over to devices. There it is, staring at forever.
And that was pretty fast too, sub-second I would say. So we didn't have to rebuild our entire app to get that to show up. So now, I like the color, but I think it would be nice if we had some content on top of that.
All right. So we can do that by adding that profile card. So in our fish options right now, let's go to that build function. And right now we have a placeholder container. So we're going to get rid of that, and then we're going to construct a profile card. Emily's also constructing a default fish data because right now we're not connected to our fish database on Cloud Firestore. So the fish data just has some placeholder images, placeholder name and information so that we can see what it looks like before we connect to Cloud Firestore. Now, if you're familiar with Dart, which was what we are using to code, you might be noticing, hey, Emily's constructing this profile card, but she's not using new anywhere. What's with that? Well, this is a good example of how the Dart and Flutter teams have collaborated. Flutter was saying, hey, we have a lot of Flutter users that are noticing that new is cluttering up their code because they're constructing all these widgets. What do we do? So the Dart team made new optional, and this is part of Dart 2.0. So now you can just write a profile card. So Emily's got it all written up. We're going to hit save, and it's going to hot reload. Switch over devices.
All right, we've got a pretty empty card on here. I think what I want most in my viewing of a fish is to see the big picture of the fish.
Okay. So let us modify the profile card. So if we swap back over to the code, inside profile card, let's look at their profile card's build function. That's pretty simple. We're just calling get card contents and wrapping it in a card. That's a material widget. Get card contents does three things. It's calling show profile picture, which is clearly falling down on the job. It is calling show data, and then lastly show button. So let's go into show profile picture and make it actually display a picture. Take out that container. Instead, Emily's calling fade in image. So usually we're going to be getting an image from Cloud Firestore. So that's a call to the server that's potentially asynchronous data. So when we build, we might not have that data at the moment of building. So for that reason, now you could just pass in an image, but once it has that image data, it might pop in, that could be visually jarring. So instead, Emily's making a fade in image that once we have the image, it will fade into view very nicely. And then lastly, we're specifying the fit. So images have a width and height, and it's saying boxfit.cover is saying expand to fill all the available size, even if it means cutting off some part of the image. Someone's going to hit save, which hot reloads, and we're going to switch over to the devices. Oh, it already faded in. You didn't get to see that. So fast.
All right, we've got our big picture of a fish, but I need to know more about that fish before I decide to adopt it. I want to know the fish's name, its personality.
Yes, that is very important for human-fish bonding. So let's go back to the code. Emily's going to modify show data. And we have declared 3 text widgets. The first one is the name widget. Second one is the music widget, fish's preferred music. And then lastly, preferred pH. And to display those, we're going to wrap those 3 in a column widget, which is going to stack them from top to bottom. So Emily's going to hit save. It's going to hot reload, go over the devices. Do we see it? Yes, there it is.
All right, so I can understand now this is Frank. He loves Blubstep. His favorite pH is 7. But the information's a little cluttered right now, and I feel like his name's probably the most important piece of this. So how could I set that apart?
All right. So we can do that by setting the text style. So instead, how about we make it bold, and we could double the font size. That would help it stand out a little bit more. That way people can look up Frank by name. So let's look at the devices again. Oh, that's much better.
Okay, I think we're getting there, but I still think the Frank should be a little bit apart from the rest of the information.
Okay, so back at the code. How about we wrap that text widget in some padding? Now there's a really handy feature with Visual Studio Code, which is what we are currently using. This also works in Android Studio and IntelliJ. You can just wrap a widget inside of another widget. So it takes care of all the indentation for you. So Emily's going to wrap this in some padding. It's done. We're wrapping it in 8 pixels of padding, which is good enough for us. So we're just going to hit save, hot reloading, and look at our devices. Much better.
Okay, so I think that the card is in a pretty good place, but I'm a little tired of looking at Frank. What if we got some real data in there?
I like Frank. But okay. So let's connect to Cloud Firestore. So at the top, that My App. Right now, we are passing in an empty list because we're not getting any data from Cloud Firestore. So instead, we're going to be making our call to Cloud Firestore. So there are 2 different ways that you could deal with asynchronous data because we're making a call to the database or Cloud Firestore to get our information. The first way to deal with asynchronous data is futures or promises, depending on where you're coming from. And this is if you want 1 bit of data asynchronously. Streams are your other option. Now, streams are if you need multiple pieces of data. In this case, we want a snapshot of all the information on Cloud Firestore, and then when something changes on that database, we want to get a new snapshot of all the fish that are still there. So in this case, stream is the correct option. And then there's this convenient stream builder, which allows us to build widgets from the stream. So Emily has specified the source of the stream. This is from Cloud Firestore. We are getting a collection of fish profiles. And then we are calling the builder to build widgets based on that fish information. You might notice on the line 32, we have this interesting question mark syntax. What's going on there? So what we're saying is data null? If it is, don't call .documents. And then you can return that empty list or assign that empty list to the documents variable. Otherwise, get the documents from Cloud Firestore. And then we're taking that map and converting it to a fish data object. So we have a list of fish data, passing it into fish page. Now, you might be wondering, how are we accessing this Firestore variable? Well, if you scroll up, to the imports, you see we have these package imports, particularly Cloud Firestore. Where does that come from? Well, if you go over to PubSpec, this is just a YAML file that allows us to specify all of our dependencies for Dart. And the pub, which is our package manager, is able to calculate all of the versioning things, pulls them down from online, sets up all the paths correctly, and then you're good to go. You can just import them. So back to our main file. We have one more change we need to do, because if you recall, Emily constructed that fish data object that was default, it had no information. Now we want to take that stream that we just got from Cloud Firestore and display it. So here she's saying, if we have data, just call the first one, because we're only displaying one card right now. So now Emily's saved, it's hot reloaded. If we switch over to the devices, we've got some good data.
Okay, I'm looking at Flo, and I'm feeling pretty good. I think I might want to adopt her, but I'm not really sure how I could do that from this view.
So, for the sake of time, I'm going to cut that short because we want to have prize drawings in a little bit. I just want to show the main website and some of the stuff on there. So, to get to a lot of the content that Google has available for Flutter, you go to flutter.io, and there's some information here, and they're at beta level 3, but there's already people that are using this framework to build apps and deploy them to the Google Play Store and iOS App Store. If you follow Twitter, there's a group of people in the Flutter community that are already talking about apps that they're publishing. They're linking to a lot of tutorials and content on Medium. If you read any articles on there, people are putting stuff on there as well. But you click on Get Started, and here is a good place to start from. They have the install, so depending on your platform, they have installs for Windows, Mac, and Linux. You click on those and it'll download a file, and then the configure your editor. As they mentioned in the video, there's Android Studio and Visual Studio Code. Depending on which IDE you prefer, they have steps to go through to get that set up. And then they have a test drive where they basically, you set up a starter app, and it's just whenever you start a Flutter app, it kind of builds the beta that exists will build an app that will run and compile, and when you run it, it basically looks like, well, it's not a big enough picture, but basically looks like this, and it has a title at the top and text in the middle of the screen. From there, that kind of will let you know whether or not you have everything set up. And if you have a Mac and you have Xcode on it, you can launch the simulator, and this is the end of the app from the step 4, but give you an idea of what. So one of the things you can do is you can deploy the app to both simulators, or if you have devices, you can do that. If you have a Mac, you can load the iPhone simulator. If you have a Windows or Linux, you can get the Android emulator, but you need a Mac to get the iPhone. But you can also deploy devices. So from this starter app, what step 4 does is it kind of goes through these 7 steps to convert the starter app here with the text in the middle and the title. It has several steps. So one, you have basically hard-coded text, and then the main.dart file, I'll kind of show you this here. As with the demo they showed, all the code they have for the app is in the main.dart file, and then a lot of the dependencies they mentioned with some of the stuff they added is in that YAML file for this specific demo number 4 step 4 demo. They add this English words library, which I'll show in a minute. But so all the code is in this one, for this app is in this one class file. So you start out with an app that basically has hard-coded text. You add a function to generate, well, you add the stuff for the English words. You add a import and then a class to call this random word function, so that then if you were to hot reload the app, it will change the text display. So instead of it having it hard-coded with the words hello world as you would see here, it's going to use, this is commented out, it has another text object where it actually pulls in a word pair and shows it. So it's basically the app cosmetically looks the same, but the words are random. So it comes up with a random word pair. So then the next step, step 3, it has you add a stateful widget. So instead of calling a single method for this text box to show the text, you're actually adding 3 class files: a random words class, a random word state, and a where is it? Oh, that's actually just 2 classes. Sorry. And then you change the code in the my app file, which is basically the main class, to use these new methods you generated or put in there, the classes, the random words class, to basically do the same thing as calling that random words thing and creating a word pair. In step 4 of the tutorial, you're adding some variables and some methods within the random word state class to basically build a list view on there. So as you go through this, there's a couple things in here where you add the list, add the component to build the row, and then you end up converting to this. So you get a list of word pairs instead of just one word pair on the screen. And then step 5, you add interactive activity to the app. One of the things, if you notice on these 2 simulators, there's an icon over here on the right. Within this app here, so you have the scrolling list, and if you like T-Earth, you can say, oh, it's a favorite. So this stuff here, this code, is adding this icon to the right to allow you to save items that are favorites. And then this next method is on tap, which actually allows you to, this requires 2 parts. One adds the icon, the other one adds the interactivity. So then you get to the version I showed you. And then one of the last parts of interactivity you add is a navigation stack to the actual app. So the steps there basically walk you through adding this icon up at the top, which once you add the icon, it doesn't really do anything. But and then you add a second list view into a second screen, so that when you click over, anything that you have saved as a favorite on the first screen is now, so you see there's 4. If I remove 2 of these, there's 2, and this is the same thing with the Android app. So I have both emulators running. To give you an idea, like when they're talking about the hot reload, if I step back over here, if I come in here, so up at the main, I have a color right here, and it says color white. So if I was to change this to color red, and as you know, the IDE over on the left, it shows a color. So if I was to change that to green, the IDE, and then this is something that's, I don't know, Xcode doesn't really do this. So that shows that. If I do hot reload, let me actually pull both of these up. Actually, I only have one of them set. So this is the Android emulator. If I do hot reload, you'll see the UI should, actually it's not running. Yeah, so, and so you see this name up here at the top. I could change this to GDG name generator, give you an idea how fast the hot reload is. Actually, that's not, no, did I click that? Demo fail. What? Oh, wait a second. Sorry, I was changing it in the wrong place. So that's, and then you can also, so you have this drop down. I have 2 phones connected. So I have 2 simulators, the iPhone X and then this Android one. Then I have 2 Android devices. And it's pretty easy to walk through. One of the nice things is they give you the actual iOS and Android projects are in these iOS and Android folders up here. So if you're used to building standalone applications for each one, everything that you would normally see in one of these projects is in the other one. And one of the things you can do is you can come in here to this project and you can right click on it and do Flutter Open iOS module in Xcode. So what that actually do is open the Xcode project in Xcode itself and show you just that piece of the code.
Do you have to download any kind of app to your phone?
No, that's interesting. So when you're running in debug, one of the things they do is you're not actually running the APK or the iOS IAP or IPA on the device. It's actually running like a virtual machine, which is how you're able to hot reload so quickly. The framework actually compiles using Android Studio and Xcode build commands, like terminal commands to command line commands to build in the background. So it never has to launch Xcode in interactive mode to compile your application. So if you actually compile it for release, it will compile it using command line scripts to compile the code. But when you're doing a debug, it's just a VM. You do, for Android, you have to have the device set for USB debugging. For iOS, you have to have a developer certificate, which you can get for free now. I think it requires money to actually publish stuff to the store, but they do allow people to get free developer licenses and get a certificate. So if you just want to develop stuff to learn, you don't have to pay them $100 a year to get a license to publish stuff to the App Store, which is something they used to do years ago. Does that answer your question? So go back. So one of the things I'd like to do in the coming months is, we had some people at our last event ask if we could do more hands-on stuff. So one of the things Tim and I were talking about was potentially having a meetup where we allow people to bring their computers, and we can kind of have an interactive session. So we can pick some code labs with this, and if this is stuff that people are interested in, we could do that. One of the things I was going to do is maybe have some instruction stuff beforehand, maybe have one or two hangouts that are kind of short, just so everybody, before we have the initial hands-on meetup where everybody shows up, kind of make sure everybody can get their computers configured, so that we're not spending time. I mean, it doesn't take a lot of time, but we don't want to have everybody, downloading and taking 30 minutes of the meetup to get everything configured. So, so if people are interested in that, we'll probably potentially post something and have something about that in the next, maybe July or August, before.
Yeah, it's kind of like a study jam. Yeah, we've done our study jams. We met the Flutter team last month, and I'm pretty sure they'll send us some stuff.
They're
even if they give us a sticker fighter.
Yeah, there's a lady that used to be one of the organizers for the GDG North America. She now is actually on the Flutter project team. So if you actually go out there and look at some of the Flutter people, she's posting a lot and liking a lot of content. There's a few Flutter and Dart GDEs out there that are posting content. So anyway, back to the website. There's this main thing, this code lab I was showing you. There's also some stuff here on the left. There's a widget catalog, so you can go through and it kind of shows you some coding examples for all the different widgets, kind of walk you through that. There's a cookbook here, which is kind of like an HTML version of a book. You can go through, it kind of gives you instructions on building something that's a little more in depth, gives you a little more background about what you're doing with the language, stuff like that. The samples catalog, which goes through a few different sample libraries, app designs that you can build. Some layout tutorials. There's also Flutter for web, Android, iOS, and React Native dev. So if you have a background in a certain platform, they have like a starting point for web developers to get more exposure and understanding with Flutter programming. So anyway, this is a little intro. We didn't have a lot of time for this, but we do plan to have some more stuff in the future. So.
All right, so what we want to do now is get everybody's names and stick in the prize wheel.
Peter.
Is this a new prize wheel?
A new what? This is the one I got off of the GDG community site. It's from a post that Martin had in 2016. So. Oh, yeah.
That might be the one that he
Which?
actually made.
What's your name, sir?
James.
Oh.
Jordan.
Oh.
James B.
Jordan.
Oh, you're Jordan. Oh, sorry. What's your last name? Oh no, the general.
Jordan. Yeah, just put S. It's
Okay.
all we'll take you out.
That's. Still okay. Hope I spelled it right. So your name? Huh? Tony. Tony. Sorry. Okay.
So you can do Dart in
Visual
Visual Studio 2?
Studio Code. So if you go to visualstudio.com, Microsoft has a few different versions of Visual Studio. There's the one that they've had out for.
You can get the Express.
Well, they. What is this doing? That's not the website I wanted to go to. Visual.
No, it's Visual Studio Community.
Oh, the
Professional
Community
Enterprise.
Community
Visual Studio Mac, which used to be Xamarin Studio.
But they also give you a bunch of, you can do, they give you phones and tablets, virtual phones and tablets.
Yeah, this is. So Visual Studio Code is more of a text editor, but it does allow you to do compilation of web apps, and it has IntelliSense in it. So if you're familiar with the Atom IDE, or what's the other one that a lot of people use? I can't think of it. No, there's another one that starts with an S. I can't think of it.
Sublime Text.
Yeah, Sublime Text. So that's another one that's really popular. So if you're familiar with Visual Studio itself, it's a very robust and in-depth IDE. This is Visual Studio Code, which is basically has a few icons on the left, has a folder structure hierarchy kind of expandable thing over here on the left. And this is actually a Dart project I was working on before, but this is the IDE they were using in that video. So it has tabs at the top, and it's actually downloading some stuff. It has a lot of plugins. Yeah, the plugin library is very extensive. The language support, I don't use it a whole lot, so I'm not. There's probably several people in here that can use it better than I can. But there's a lot of stuff that you can actually. But this is what the IDE looks like. If you're familiar with Visual Studio itself, this is a lot different than that. But this kind of focuses, as I guess per its name, code. But one of the nice things with this is this was one of the first IDEs that Microsoft released that runs on that looks the same and runs on Mac, Windows, and Linux. And it on the back end, I believe, could be wrong on this, but they started out with .NET Core 1.0, which was the .NET framework that they were building out to run on all three platforms. You can do ASP.NET applications in this, and it gives you IntelliSense, and it supports MVC, stuff like that. I'm not sure if you can compile Windows IEXE apps or stuff like that in it. It's mostly web or other types of scripting languages. But anyway, that's what Visual. But if you go to visualstudio.com, you can find it. So they had the Visual Studio IDE, the team services, and then they have Visual Studio Code, which this is the IDE I was just showing you. This is the Studio IDE is the one that people are probably familiar with, that you build all the different Windows applications over the last 10 to 15 years. And they've obviously upgraded and whatnot. But so, Michael, is there anybody else in here? That's everybody. So we'll spin. Do you have more than 8 prizes?
Well, we got these two.
Okay.
But everybody's going to get a t-shirt.
Oh, okay.
You can take mine. I have one of those. Yeah, I did too.
Okay, so.
Didn't you get the refrigerator? Refrigerator? Yes. I don't remember who got it. I got another one. Little Stanley refrigerator.
We also, in addition to shirts, we got hats this time, but they're being delivered tomorrow, so it's not very convenient to. But
I'm gonna hang out for another 12 hours.
Yeah.
Dress like us. If anybody wants one of these shirts like these, we've got some, plenty. But let's start with these. Anybody wear extra larges?
Can I see the extra large? Really extra?
that shirt is the one that Tim's wearing, by the way. If you... No, I just meant the design. It's, I guess, obvious, but.
Microsoft is going to feature merge their Visual Studio Mac and their Visual Studio Windows line.
Yeah,
they have a really neat new plugin on Preview called IntelliCode.
Okay.
It is, they are GitHub.
Yeah, they just bought them. Was that 2 weeks ago?
Run machine learning on GitHub. The entire repo.
Yeah, I saw
now when you code, that machine learning model will basically do recommendations for your code.
Yeah, I saw a talk, or no, it was in a podcast. They were talking about a few years ago. They put their entire Windows OS base, which includes the Xbox and all the other different servers and everything, because I guess when you build for a certain platform, you pull components down and you don't use the whole thing. But they're saying that the source code for that was like 390 gig for just the text and I guess images for what assets. And if you're on the Xbox team, you don't need the entire, so it'll dynamically link to whatever modules you need. That's pretty cool. I mean, I think there's a lot of people that are kind of negative on the whole GitHub purchase, but I think seeing what Microsoft's done over the last 10 years, I don't think it's the doomsday that some of the open source community might be. No, they're not. So,
You see that new, the Azure development is actually bigger than Windows development now.
Yeah.
So Microsoft's all on Git.
Yeah, that's what the guy was saying in that podcast. Yeah, they moved from
TFVC.
Yeah.
TFVC allowed to do what you were talking about. Put the entire repo up on the cloud, and you basically mask out the stuff you don't need and just pulls down what you want.
Was that IntelliCode thing something you saw when you went to build, or something? Okay.
They demoed it, and it's actually on preview now, so you can go up and grab the extensions.
Yeah, that's cool. I think it was last year, a year before, I toyed around with Visual Studio on the Mac, and you could do ASP.NET MVC apps and stuff.
It's actually a lot more feature-rich now.
Oh, I don't doubt it.
Building out it started from Xamarin Studio, and there's Visual Studio. The 3 on Windows is their little baby. They're pushing more resources on that, but they are looking to bring Visual Studio Mac right up to feature parallel with the straight out Visual Studio.
Yeah, that's.
I think they're looking to do the write once and run it everywhere from a pure software company.
They have this, you see that, I can't remember the name of it, it's like WhatsApp, but it scales to like 5 million users. It's basically like last time. You released it like in India.
Yeah. Okay.
you have another large?